Okay, we're going to get started in just a few seconds. There is plenty of room in the front if you guys want to come closer. I don't bite. My name is Silviu Niculita. I came here yesterday using two really small planes, turboprops. The bad thing with turboprops is when they come into land, they do this. And I hate it when planes do that. So, but it's certainly worthwhile. You guys have a very beautiful city here, an awesome technology environment, clearly, given how many folks are attending this event, and I am very grateful to the organizers and the sponsors for including me. We are going to be talking about machine learning today. Big surprise, right? I think this is the fifth or sixth session that deals with the subject. So just to set some expectations, the second speaker that delivered a session in this room, who attended his session about catching corrupt politicians in, so quite a few folks. So what I'm going to do during my session is show you guys how you can check up on your own politicians without having to know a lot of sophisticated stuff about Python, R, machine learning, data science, statistics, and mathematics. So that's what I'm going to pull off. Now, unfortunately, Mikhail, the speaker who was here before me, took my thunder away by showing machine learning Azure ML a little bit. But I'm going to go more in depth about the architecture of that particular solution, and we're going to have a lengthier demo about how to do supervised machine learning using Azure ML. So that's just to set expectations a bit. Now, I certainly do, while I love to hear myself talk, my wife says I love to hear myself talk, I don't want to sit up here and deliver a 50-minute long monologue. So in order to incentivize you guys to ask questions throughout the presentation, I have brought candy. I brought the candy with me from Romania, because I did go to a conference once and I couldn't find a store, so I was in trouble. So this is German candy exported to Romania and then imported to Poland by me personally on two really small turboprop planes. So it had quite an adventure in terms of getting here. Now, the way you get the candy is you ask a question, and before anybody who's a smart aleck and says, oh, can I get a box of candy? No, it has to be a question pertinent to the presentation. Because I had somebody once, oh, what's the weather like outside? No. And it is first ask, first candy. So that's how we're going to hand it out. Good. So our objectives for today are to define and explain what machine learning is and what industry verticals it can be used in with some real-world examples, and I'm going to have some really creative ones as well. We're going to do an overview of Azure Machine Learning, which is Microsoft's cloud-based solution to the entire ML space. We're going to have a hands-on demo of the technology where we are going to, we'll have to see. I generally use two sample data sets in this demo. One is a list of all of the passengers in the Titanic, and I try to guess if, based on certain input data, you're going to live or not. But that's slightly morbid. So we're probably going to stick with something more benign, which is some US Census information, and we're going to try to guess people's income based on a set of attributes. At the end, we're going to have a recap and conclusions, and then a few minutes at the end for questions and answers, and candy, obviously. Okay, what is machine learning? Do we have anybody who works as a data warehousing person, data scientist in the room right now? A couple of folks. Okay, excellent. I am envious. So data scientists are the practitioners of this black art that we keep hearing about in machine learning, and they are a very interesting and special breed of people because they live somewhere. So they're either statisticians that know far too much about programming, or they are programmers that know far too much about statistics. Is that right? Close enough? Oh, they're nodding their heads. Okay, so I'm close. Now, what I'm going to hopefully show today is how you can enter the machine learning space without obtaining a master's or a PhD in statistics, and how modern tools like Azure ML democratize access to ML. Now, You might think, machine learning, maybe this is how you do it, right? You've got young, small machines, and you put them in front of a bigger, wiser machine, and that's how they learn, right? Machine learning. But not quite. Right? So my favorite definition is not from Wikipedia, it's from Tom Dietrich, who is a distinguished professor at a university in the US. And he says the goal of machine learning is to build computer systems that can adapt and learn from their experience, right? Just like with wine, it gets better with age. Software systems should get better with age. So that's the value proposition for machine learning, right? And it's all about using data to predict the future. And there's all sorts of business applications to machine learning, right? Churn analysis. This is done especially by telecom operators, right? We all have smartphones with data plans, with voice plans in our pocket, and sometimes we switch providers. Now, it is really valuable to your current provider to know when you might be tempted to switch, because it is much cheaper to keep an existing client than it is to bring a new one on board, because a new client will most likely demand a discounted iPhone or all sorts of other benefits. So what they do is they build models around your usage patterns. How many text messages are you sending? How much data are you using? How many phone calls are you making? And try to predict the likelihood that you will switch operators, right? Social networks. All Facebook is a big machine learning implementation. And you are the subject. It tries to figure out what your hobbies and interests are so that it can serve you better advertising and obviously make more money, right? Recommendation engines, right? If you go to an online site, you buy one product, it starts recommending, oh, other people bought this thing as well. Oh, you bought a TV, you're probably going to want a receiver or HDMI or some other thing with it. Weather forecasting, equipment monitoring. There's a lot of interesting things going on around predictive maintenance. And I actually am working on an initiative right now to do this for airplanes, right? So all modern equipment has a lot of sensors, and it produces a tremendous amount of information. And with that information, you can predict when a certain component in a piece of machinery, be it an airplane or a truck or an elevator, is likely to break. And once you have enough of those pieces of equipment in the field, you can start noticing patterns like, oh, the belt on this type of Mercedes truck fails between 80 and 90,000 kilometers. And it is much cheaper for fleet operators to preemptively replace that belt at 70,000, right? Simply because otherwise, the truck breaks in the middle of nowhere, you got to send a different one to pick it up, etc. And then when it comes to elevators, it's especially important because nobody likes to be stuck in an elevator, right? Fraud detection is, again, a really good one. It's about noticing peculiar patterns in streams of transactions. And I was the victim of credit card fraud twice because I travel a lot. I use my credit card all over the place, apparently too much. And I had it compromised twice. And it's a big pain in the ass because you've got to file a police report. And where the IT fraud department in Cluj-Napoca, which is my hometown, is next to the guys that handle drug issues. So it was me in a waiting room with drug addicts waiting to file my police report about my compromised credit card. So that was not fun. And in hindsight, it would have been really easy for my bank to notice that something was wrong. Because in theory, at the same time when I was buying gas somewhere in Romania, I was also ordering pizza in Puerto Rico. Right, so how likely is it that I'm doing both transactions at the same time? Hopefully they've gotten better since then, because for some reason I haven't switched banks. Now, why should you care about machine learning? Now, has anybody here heard about Gartner? Okay, a few folks. So they are a market research firm, and what they do is they put out expensive reports every once in a while, and this is their emerging technology hype cycle. And what they do is they plot people's expectations on a time series, right? So, and technologies have life stages. that they move through, right? There's an innovation trigger, right? We come up with something new and figure out how to do something, right? Then there is the peak of inflated expectations, right? This is when the technology is a teenager, okay? Trough of disillusionment, mid to late 30s, slope of enlightenment, 40s and over, and then you reach the plateau of productivity at around 50, right? If we were to draw a parallel to a human life. And various technologies move across this chart at varying speeds, right? Less than 2 years, 2 to 5, 5 to 10, and more than 10 years. Now, machine learning is way, way up here. So everybody assumes that it's going to change everything, right? But the good news is, it is moving very quickly. So in 2 to 5 years, it is going to reach the plateau of productivity where stuff actually starts working and having an impact on the world. So if you guys are considering potentially diving into this space, now is an excellent time to do it, right? Because you will be well prepared to become a highly paid data scientist in the next 2 to 5 years. Right. Now, I gave a lot of sort of boring industry examples of uses of machine learning, but who really cares about, changing parts in trucks, right? So I have a lot of Google alerts about the machine learning space, and I come across these things and I add them to the slides. So one of the interesting things that Microsoft is doing, they have a research lab in New York that focuses on artificial intelligence in general. And one of the things that they do is try to predict Oscar winners, right? And they're getting pretty good at it, right? So in 2013, they got 19 out of 24, 21, 20, and 17. So when you think about it, successfully guessing 20 plus out of 24 is really good from a statistical point of view. For some reason, they went downhill in 2016, but they did successfully guess that Leo would get his first Oscar, which absolves them of all sins, if you ask me. Guessing the outcome of political elections, right? So they successfully guessed that the Scottish referendum would end in a no vote. So they guessed it would fall between 51 and 59%. The result was dead in the middle at 55. Midterm US elections, 34 out of 35, 419 out of 436, and 33 out of 36 seats for state governors. So that is extremely precise. If I was running a gambling site, I would be suitably intimidated by the level of accuracy that these guys can achieve. Now, that being said, they do screw up, right? Brexit referendum. They anticipated that the British would vote to remain. As we all know, that wasn't really the case. And another even more painful one. I was speaking to the gentleman who's going to deliver the ending keynote today, and he is a federal employee, and so he's directly impacted by by the outcome of this particular political race. So obviously, 84% chance to win for Hillary Clinton didn't really pan out, and this was taken a couple of days before the election. So they obviously screwed up, and this just goes to show that the quality of the prediction is only as good as the quality of the data you feed in, right? And the way that Microsoft produces these results is by indexing the web. Clearly, folks that tend democratic are more likely to be present online to produce more content, more blog posts, more articles. Folks that voted for Donald Trump don't tend to spend or produce as much content online, which biased the initial data set, which biased the result. And there we have it. Another fun example is from retail. And this is from a New York Times article. There's a chain of supermarkets in the US called Target, and they employ dozens of data scientists. Now, you might wonder, well, why would a retailer employ a data scientist? Well, it's simply because the market is so competitive that they need any single type of advantage in order to increase their market share, their revenue, and then their profits. And one of the data scientists working for Target produced a model that, based on your purchasing patterns, if you're a woman, could predict with an 86% level of accuracy, I think, if you're pregnant or not. Think about that. Your supermarket might know you're pregnant before your spouse does. So that's a bit spooky if you think about it. So, and there's an interesting anecdote in the article about something that happened in the US where Target actually sent a teenage girl an ad for baby products, a bespoke addressed to her, 20% off diapers. And the young lady's father walks into the local Target store. He's very angry and he says, "Listen, you jerks are sending my daughter ads for baby products. Are you trying to convince her to start having kids? You've got cute pictures of kids here. They're not that cute when they're growing up." And the store manager doesn't know how to apologize more and says, "Listen, I'm going to make sure that we stop sending your daughter these ads." And he takes down the guy's information. And a couple of weeks later, he calls the angry father and says, "Listen, sir, I've made sure, I've called corporate. We've taken her off of our marketing lists." And the father's tone is completely changed. And he says, "Well, actually, sir, I think I have to apologize to you. It seems some things have been happening in a house that I did not know about, and I'm going to become a grandfather in 7 months." So there you go. Fighting poverty, right? So leveraging satellite images to detect pockets of population in sub-Saharan Africa that might be starving because of droughts. And this is very creative. They actually use daytime photographs and nighttime photographs, and they try to identify inhabited spots that don't have electricity, so therefore might not have a means of communicating and asking for help. It's really interesting what they're doing. Healthcare. Right? It's all about increasing the accuracy of diagnoses, right? So it correctly predicted those who would still be alive after 1 year about 80% of the time, so 20% better than doctors. And this is a machine learning algorithm. Creating cancer treatment plans. 96% of the time for lung cancer, 93% of the time for rectal cancer, and 81% for colon cancer, right? So this is how often IBM Watson was in agreement with a doctor, which is remarkable, right? Another one is around saving bees. So apparently, bee populations in Europe and in the US are impacted by a parasite. It's called Varroa, I think, or something, Varroa. So it's this really, really tiny tick that attaches itself to the back of the bee and literally sucks the life out of it, and it kills it. And there's only one way to kill them. There's an insecticide you have to spray, but the problem is if you spray them too often, the parasite becomes immune to the insecticide, insecticide, and they, kill your bees anyway. If you spray them too late, there's too many of them, and you still lose your bees. So you have to get them at the right time. The problem is, bees are small. Imagine how small this thing is, right? And what this is actually a Kickstarter project. So a beekeeper in Sweden is raising funds to build an iPhone app that has machine learning in the back end. So you take a picture of your beehive, and it figures out the number of bees, or the rough percentage of bees that are impacted by this tick, and it tells you if you're supposed to spray or not, or if it's already too late. So this is fascinating. Right. Now, what sort of problems can we solve with machine learning? Well, you can use it in spots where automated prediction is core, where you have lots of existing data. If I can go back to the bee example again, the biggest challenge is not actually building the back end, because that's easy. Their biggest challenge is collecting pictures of beehives and knowing how many, what the infection rate is. So what beekeepers have to do is they have to take a picture and then essentially have to kill those bees in alcohol, which causes the ticks to detach from the bee, and then they count them by hand. You can imagine how tedious that is. So wherever you have an adequate amount of data is where you can leverage machine learning, and where your current system relies on numbers that somebody made up a long time ago, right? You can't really apply it when you don't have any past data, when many business rules govern the experience. We tried it, for example, when one of the clients of the company that I work for produces software for all of the pharmacies in the Netherlands. And we tried to build a recommendation engine for them. Oh, if you bought this painkiller, you're most likely going to be interested in this other product. Apparently in the Netherlands, that's illegal. So that went nowhere, right? And where predictions do not have a predictable pattern. So that's where you can't really use machine learning. There's two major categories, as Mikael mentioned, of machine learning. There's supervised and unsupervised. Supervised is the easy one, where you try to put stuff into categories. Supervised is the example we're going to do in a few minutes. It's about predicting the future and putting stuff basically into boxes. And unsupervised is where you don't really have structure around your data, and it's about noticing, leveraging the machines to make sense of the data, right? Recommendation engines are a good example of unsupervised learning. Now, what is Azure ML? And before we get into that, we're going to try and tackle the problem that Azure ML is trying to solve, right? And the biggest one is access to the machine learning space is really complex because high-quality algorithms are sophisticated and they're hard to understand and implement. You have to learn a bunch of different tools. Most often, your data is going to be either incomplete or incorrect. If you're looking at an e-commerce database, for example, most of your users, if you have a job occupation field in there, they're probably going to be accountants. Why is that? Well, it's because it's the first value in the dropdown. If you have a country of origin in your data set, most likely you're going to have a bunch of folks from Azerbaijan. Again, because it's the first value in the dropdown. And people are lazy and they don't want to give you accurate information. So, the biggest challenge is what is generally referred to as yak shaving. So it's looking at aggregate counts across your columns and figuring out which value you have to throw away. Because otherwise you're going to try to market to accountants from Azerbaijan, which is probably not going to work out very well for you. Right, so you needed, up to a couple of years ago, to learn a bunch of different tools to do data acquisition, to do data cleaning and preparation. Maybe you wanted to massage the schema a little bit, to actually do the machine learning and experimentation. And then actually taking a model and productizing it was, again, extremely expensive. Right, so this wasn't a clear, scalable solution. And what Microsoft's solution to this problem is called Azure ML, right? Which is part of their, as the name implies, public cloud offering, right? So it's part of Microsoft Azure, which is their public cloud. It is advanced analytics, and it offers really easy access to world-class algorithms that you can just drag and drop onto a design surface, so you don't have to implement them by hand using R or Python, which, if you really wanted to, it does support. So you can bring in external code and leverage it in the tool as well. In terms of how the solution architecture works, there is an Azure portal. Who here has gone to the Azure portal? Okay, quite a few folks, right? So you're familiar with the experience. The Azure portal is just a web application. Fun bit of trivia. It is the largest single-page application in the world, based on code base. So that's a bit of information you guys are never going to use. And Azure Portal is where you provision your computing resources, right? And 20 plus data centers all over the world. And your operations team would go in there and they would provision for you something called ML Studio, which is yet another web application. So it's a web IDE that you access as a data scientist, or as an aspiring data scientist, and you conduct experimentation. And from ML Studio, you connect to all sorts of data sources. So HD Insight is, again, Hadoop hosted by Microsoft within Azure, but you can also connect to any type of Hadoop cluster you might have on premises. You can talk to blob storage, right? If your data is in CSV format, you can pull in desktop data. You can talk to SQL Server, either on premises or in the cloud, or Azure SQL Data Warehouse, pretty much anything you want. Okay. You do your experimentation, and once you're happy with the trained model you've produced, you convert it into an API, which a developer can then integrate into web applications, mobile applications, Power BI dashboards, or any sort of IoT scenario you might want to envision. Now, what are the basic steps that we walk through when creating a machine learning solution? Well, first, we need data, right? We can't do anything if we don't have data. We build a model, and then we turn that model into an API, which is then leveraged by the end consumer, right? Sounds really easy. And it almost is. If we zoom in a level, it becomes slightly more complicated, but it's still manageable. We have to define or redefine the business problem, right? So we've got some data. What are we trying to do with it? What are the insights we're trying to extract with it? And sometimes that's the biggest challenge, figuring out what the right question is. We extract the meaningful data. We develop a model through iterations, right? So we tweak parameters. We tweak the algorithms that we're going to leverage. We deploy it, and then we monitor its performance, right? The world changes, and therefore your trained models are going to have to be updated periodically in order for them to maintain their level of accuracy. If you develop a model, for example, to predict the price of real estate, and if you stop updating it for 2 years, what do you think is going to happen? The accuracy is going to go down, right? Because certain neighborhoods go up in popularity, certain neighborhoods go down, there's new constructions, there's all sorts of factors. And the most complex one is number 3, right? Develop models through iterations, and here we define targets and metrics, we extract derived features, select, fit, evaluate, etc., and we keep going around. It's a very agile type paradigm, right? We keep going down in circles. Okay, let's see a demo. Now is actually a great time to, if somebody's buffered a question and they're dying to ask it, or they need some sugar. No? Huh. I do not want to go home with half a dozen boxes of candy, so you guys had better start asking questions. That's all I'm going to say. Good. So this is let me close out of this stuff. So this is the Azure ML dashboard, this is the Microsoft Azure portal, and we can see all sorts of interesting things here. And what we're going to do is provision a new resource, and for some reason machine learning is under the Internet of Things, and we go define a machine learning workspace, and we feed in all sorts of parameters. The resource group is just a way of logically grouping resources, and we can provision. Now, ML is not available in all of the data centers under Azure, so Azure has around 20 plus data centers in the world. I think they just announced a region or 2 in Australia recently, so it's only available in Western Europe, on the European continent. We would provide, create a storage account with a pricing tier, web service plan, so all sorts of metadata that it needs. We're just going to go with, let's go with this one. Just use an existing storage account. Do this one, create. And this takes a few minutes so to deploy. So we're actually going to skip that and start using one that I created earlier. So go to resource. Oh, it actually finished. Huh. It was faster than I expected. So that online IDE I mentioned earlier has already been created behind the scenes, right? So at this point, I just launch it, and it opens up a new tab, and go click My Experience because I'm already signed in. It offers to give me a guided tour of the tool, which I'm not interested in right now. So I'm just going to dive in, and for the sake of brevity, create a new experiment. Now, this is my playground. Yes, please. So the question is, I'm going to repeat it so you guys can hear it and it comes out on the recording. If there's any free plan, yes, there is. So there's a 30-day trial for Azure itself, which gives you $100 or something. And you can actually, Azure ML in particular, so I might have to go into incognito mode. You can actually play with it for free for 8 hours. The only problem is, it's not going to save your trained models. But if you're just evaluating it, you're not going to care, right? So there's an 8-hour trial you can use. And boom, you're in the tool and you're off and running, and you can create experiments and see how the APIs work, etc. And it's actually not that expensive. I've got a slide on pricing at the end. You're talking about $15 or 15 euros or something to use it as a developer. If you actually productize a service and you start calling, making tens of thousands of API calls per hour, it does become more expensive. But at that point, there's a business case behind it. Good, so thank you. Setting it aside. Okay, so this is a really, really powerful web application. I call it a love child between OneNote and SQL Server integration services, right? So OneNote is Microsoft's note-taking tool, which has a very similar design surface, and SSIS is their ETL tool, which allows you to manipulate data. So we're gonna give this experiment a name. Awesome demo, good. Now, as I mentioned earlier, we need data. Data is at the heart of everything. And the good news is there's a bunch of sample data sets in here. You can also go to a website like Kaggle and pull in different data sets, but to keep it simple and for the sake of expediency, I'm gonna pick one that's already in here. And what this is the result, a fraction of the result from a US census that was conducted a few years ago. So we've got 32,000 rows, which is not a bunch of data, but it's good for just playing around, and 15 columns. So what we have here is people age, working class, level of education, marital status, occupation, relationship, race, sex, capital gains. This has to do with taxation, number of hours per week they work, native country, and income. So income is what we're interested in. And since this is a census, people are not going to tell you exactly how much they make, but apparently they feel comfortable enough to tell you if they make more than 50 grand a year or less than 50 grand a year. And that's the same type of prediction we're going to try to make as well. Now, one of the problem areas here is, there's missing values, and machine learning doesn't like missing values, right? Nulls are problematic. So one of the things we tend to do is clean missing data. So just drag this guy on here, connect the two, and this will allow me to replace nulls with, right? So I could do something fun like Narnia or a made-up country, but we're just gonna stick with unknown, right? Next thing we're going to do is clean up my data set a bit, right? So there's a bunch of columns in there, roughly 15, but I don't need all of them in order to produce my model. So what I'm gonna do here is launch the column selector. And let's say I wanna start with no columns, and I wanna start bringing stuff in. So people's age, is that gonna be relevant to how much money they make? Probably. Working class, you'd bet. Education, sure. Marital status, maybe. Occupation, yeah. Relationship, it depends. People may or may not be interested. Oops, I think I've got a duplicate in here. Hours per week, yeah. It's hard to make a lot of money if you only work about 10 hours a week. A native country, probably yes. Obviously, income. And gender and race, unfortunately, are probably relevant as well. Yes, please. I didn't get occupation, thank you. That is technically not a question, so, but thank you, nonetheless. Okay, occupation, there we go. So, the gender thing hopefully gets addressed. I've got a 3-year-old daughter, and I'd like to think that by the time she starts working, we're not gonna see imbalances in terms of pay for different genders, right. So at this point, I've dropped some columns. And one of the other things that I'm going to do is just edit metadata, which I'm not even going to explain what the heck this is. It basically explains to the tool which columns are enumerations. So I'm going to say everything is an enumeration except for age and hours per week worked. Good. So what I've done so far is just cleaning and massaging my data a little bit. So I've done some replacement of null values with unknowns. I have dropped some redundant columns. So this is all stuff that you could do with Excel if you had a few enough rows. So at this point, and I actually have to do one more thing. I have to split my data. And what that means is I'm going to, and the default is 50-50 split, so we're going to do an 80-20. So that means that 80% of my data is going to flow down through the left-hand side connector, and 20% is going to flow down the right-hand side connector. And we're going to see why we have to do that soon. Next is, I've been mentioning models, right? So we're going to, at this point, train a model. We're going to train it using 80% of the data, and we need an algorithm. And I'm going to pick, let's see, I'm going to use a 2-class averaged perceptron. Now this is sounds very sophisticated, but this is actually stuff that was developed in the 70s. So the average perceptron is the granddaddy of all machine learning implementations. I think it really is from the 70s. So I'm going to take 20-some thousand rows. I'm going to take that algorithm. I'm going to train a model to predict the value of the income column. Right? Oh, come on. There you go. Should have brought a mouse. And what's next? Well, we certainly want to see how well this guy does, right? So we're going to score it. So we're going to take the trained model, and we're going to score it against that 20% of the data. And now that's the reason why I split my data, right? I have 20% of the rows that I know for a fact how much money people make, if it's more than or less than 50 grand. And I'm going to see if my model is correct. And the fact that I have known true data allows me to do that. So at this point, I have to run my experiment. And what's going to happen now is, all of my sort of components that I have here on my experiment are going to go into a queue, and you see there's a little clock face there. Once they start executing, you get a spinning circle, and once they're done executing, you get a checkbox. And the duration is non-deterministic. These things go into sort of a global queue for the data center. So depending on how many other folks are running experiments, it might take more or less. But with 30,000 rows, it generally finishes in under 30 seconds. Obviously, since this is a demo, it's going to take longer, just to screw up my timing. But while we're waiting is a great time for you guys to ask questions. Yes, please. So the question is, how is billing done? It's based on experiment hour, and experiment hour is not defined as the amount of time you spend in the IDE, it's the amount of time it is running. And the cost per hour is actually cheap. So I will have incurred a bill for 40 seconds at this point. You're too far for me to hand this to you, but I'm setting it aside. Good. Yes, go ahead. The backend scales depending on the size of your data set. So you're not going to wait for 24 hours. But it's going to charge you a multiple of that hourly rate if that happens. So if we do visualize at this point, so we've got our incoming data, and this is the actual income, right, for the 20% comes out to 6,500 rows. So this is the correct data from the census, and this is the value that it guessed, right? So this is my prediction. And if we scroll down, it's pretty good. I'm actually not finding an error. Oh, here it is. Right. So it's screwed up here. This guy makes more than 50K, and it said that they're going to make less than that. So it's not perfect. Now, in terms of exactly how well it does, there's an app for that, or rather a component, which allows me to evaluate the model. And the nice thing is, I don't have to run the whole thing again. I just run my selected component, and it's smart enough to preserve my state and only execute that evaluation. You see, everything is still checked. Got a clock face. It's going to go to spinning circle soon, and it's done. And I can visualize again. And there's a chart, which is hard to interpret, right? So this is the, I think this is referred to as the confusion matrix. So true positives is where it guessed more than 50K and the correct value was more than 50K. This is where it guessed less than and it was correct. And everything on the the secondary diagonal is where it screwed up, right? And the most relevant metric here is referred to as the area under the curve, right? So this is a graph and the area under the curve, if we were to flip a coin, right, we would expect it to follow the main diagonal and it would be, the AUC would be 0.5, right, so 0.5. This is 0.886, which is actually a really, really good value. Anything close to 0.5, obviously you're better off flipping a coin. Anything that is above 0.9, you have to become suspicious because you're probably doing something wrong. You're overfitting your data, and when you actually launch your API, it's not going to perform that well in the real world. So if you get above 90% area or 0.9 AUC, your incoming data set is probably not diverse enough. Okay. And the neat thing here is you can actually, shift, select, copy, and paste. And you can actually compare multiple algorithms. So I used a 2-class average perceptron because the name sounds really, really cool. But there's actually a bunch of classification algorithms in here. So if you pick something called a decision jungle, because it sounds cool as well. So we're going to train it. There we go. We're going to take 80% of the data, plunk it in here. Oh, it already knows that I'm supposed to do income because I did copy and paste. I'm going to score it against, again, 20%. And the nice thing is the evaluate model component has 2 inputs, so I can actually do a side-by-side comparison of 2 different algorithms and have them duke it out and see which one does better, which is really neat. Again, while this is running, great time to ask questions. Yes, please. If there's a code editor, there's no code editor, so you can't get to the code behind for this graphical representation, but you can bring in custom R and Python code. There's an execute command component, which allows you to plunk in, so I'm actually going to hand this out physically, just to show that I mean it, and I'm not going to keep them and eat them all at home. So hopefully that'll incentivize you guys to ask more questions. So you can't get to the code behind the solution because it's platform as a service and it's proprietary to Microsoft, so you can't technically take it out and run it elsewhere. It relies on their back-end infrastructure, so you are to a certain extent locked into them as a vendor. Okay, did that answer your question? So each component, so each algorithm has a variety of parameters, and you can change those. I am not a data scientist, so for the life of me, I couldn't tell you what the heck number of decision DAGs is, but the default values are good enough for me. So a professional data scientist, like the 2 we have in the room, would be able to define what that, no? Yeah, so there is an API that allows you to do certain things, like programmatically updating a trained model. That is possible, but I'm not aware that there's a way of actually programmatically creating an experiment. Yeah, and I think I saw another question there. Yes? So the question is why it reran the entire thing? Just because there's 2 options down here, run and run selected. I just hit run because I was lazy. It probably just re-executed the whole thing. There's limits to how smart it can be about, not re-executing everything. So if you just add a couple of components that are additive, so at the tail end, but if you inject something in the middle, if you're doing an additional row filtering or you're dropping some additional columns, it is going to have to re-execute the whole thing. So, and it's actually finished. And what we have here So let's see, 0.886, 0.883. So it seems that the average perceptron wins out. And obviously, this is about I think 8 or 9 binary classification algorithms in there. And what you would do potentially is, sort of like winner takes it all, right? So the guy that wins stays on the field, and you bring a new contender in, and then at the end you have figured out which algorithm is best suited for the task at hand. And you can obviously tweak the columns that you bring in. So maybe educational level isn't that relevant to guessing people's income. The good news is you can try it with it, you can try it without it, and see which one produces the better area under the curve. Now, quickly, because I'm very rapidly running out of time, what I'm going to do now is actually, so this is awesome, right? But you can't really use this in a web app or a mobile app. For that, we need to convert this awesome demo into an API. So what we're going to do here is we're going to take the winner, right, so the average perceptron, and convert it into an API. So there's a manual way to do it, and then there's a awesome way to do it. So we're going to do the awesome thing. And I want you guys to pay attention to the design surface, because it actually does something really cool. It does a whole dog and pony show about animating the way this thing works. So, awesomeness, right? And it's actually not that, right? Because I have to do a few manual tweaks. So web service input connected down here. And in terms of the, I actually have to do another, this is not mandatory, but I'm just OCD about it. So there's, no. Slightly nervous, so I'm just going to skip this thing. So I have to run it again. What I was trying to do is actually keep from having to feed in the, I know what I did wrong. I'm going to stop it, do it again. There we go. So break this connection. So I don't need to feed in the income anymore. And this is just a UX nicety. So I'm going to tell it to begin with all columns and then exclude income. There we go. Okay, so I'm going to run this guy again. And I'm going to getting close to the interactive piece here. Again, great time to ask questions while this guy is running. Yes, please, in the back. Yeah.
It can only run online. I cannot export and run it on a device like a mobile phone.
So the question is if you can take this and run with it. No. So the back end has to run on the cloud. You can't export it and run it. I think Android recently came out with something, right? And Apple as well with technology around running machine learning on the mobile device itself. No, so this is not amenable to that. There are other Microsoft solutions out there that allow you to push essentially machine learning to the edge, to Raspberry Pis and that sort of thing. This is not a solution that does that. No, this is, you have an IDE, you create your experiment, you produce an API. So this is very much a cloud-centric solution. Yes, please. So the question is if I have any reference material about how to use machine learning with e-commerce. I have a series, so I have a reference slide at the end of my session, and there's a lot of literature in there. And I think there's a Microsoft session at an event that deals particularly with the e-commerce, but I'd have to double check. So off the top of my head, I can't point to, there's this presentation done by this guy 6 months ago. for e-commerce in particular. So what I'm doing right now is I'm actually taking that experiment and creating it, exporting it more or less as an API that can be then called in through other mechanisms. So there we go. And this guy has, you can call in from Excel, from there's sample code here in C# Python, and there's a batch request mode, which allows you to essentially give it a CSV, right? So if you have a bunch of people that you want to guess the income for, you can do that. There's a batch mode, and then there's a request response mode here. So you can see that all it actually does is, issue a HTTP request. There's an API key in here, so it's really easy to integrate. And in terms of showing this working, because otherwise you're not going to believe me, I'm going to test the web service. No, I think I'm in the wrong one. Also demo, test web service. No, I'm supposed to have drop downs. There we go. So let's see. Somebody that's 33 years old, that works in the private sector, that has a bachelor's degree, that is married and is also a civilian, whose occupation is, technically I'm an executive manager, but in reality I actually do tech support. So I'm a husband, I am not an Eskimo, so I'm white, I am male, I work roughly 40 hours. So unfortunately there's no Romania in here. So I'm just going to pretend I'm from the US. So I'm going to issue an API. And good news, more than 50,000. I wish that was true. Now let's see. And let's see what happens if, for example, I get divorced. Crap. So remind me to call my wife after I'm done speaking here and tell her how much I love her, because apparently getting a divorce screws up your income here. So I ran a bit over time, but this is a very, very quick rundown of the capabilities of these tools. And over the course of 10 or 15 minutes, we pulled in a data set, we cleaned it, we massaged the data, we evaluated 2 binary classification algorithms in terms of their accuracy, we split the data, and then we produced an API that we can call a RESTful API that supports point-in-time requests or batch requests that can at this point be integrated into any sort of applications that we want. Now back to the slides. Good, recap and conclusions, right? The confusion matrix, if you really want to get good at this and you want to become a data scientist, there's a bit of statistics you're going to want to start understanding. There's, the true positives, the precision, the accuracy, the recall, which are just ratios. The machine learning rule of thumb, which is really important. So you have your data set and you set some of it aside to actually evaluate your model. I've seen people use 60-40, 70-30. I go with 80-20. Do I have to be a data scientist to use this tool? Clearly not. I barely know what I'm doing, and I was still reasonably successful at demoing it, right? And Microsoft has all sorts of documentation online that helps you. So I showed that attribute for the decision forest. I think that was very confusing, but the good news is at the bottom of that properties pane, there's a very, very extensive help page that goes into details about what parameter does what. And Microsoft also has this neat cheat sheet that helps you pick an algorithm, right? So we start in the middle. What are we trying to do? Predict categories. Are we doing 3 or more categories? No, we're actually doing 2. And we look at the 2-class average perceptron, which we actually picked. And there's a neat description here: fast training, linear model, and I think we compared it to the decision forest, which is accurate and it's fast to train. But we could have compared it with potentially a 2-class neural network, which is accurate, but it takes a long time to train it. So there's a trade-off in terms of these things. Right, so do I have to be a data scientist? No, but it helps. Competition, hell yes. All of the major cloud providers have an offering in this space. Amazon is in there with their machine learning solution, which was released in 2015. There's the Google Prediction API, which, as the name suggests, is an API. So good luck with that. And there's a lot of benchmarks out there. The problem with these benchmarks comparing and contrasting these solutions is, given that it's such a competitive landscape, these products are iterating very, very quickly. So if one picks a winner 3 months down the line, that might not actually be the case anymore. Right, so these things, take them with a grain of salt, check when they were last updated. Pricing, I think I got a question from pricing earlier. So in order to give an individual access to the IDE I showed, costs $10 or 845 euros per seat per month. And the neat thing is, this guy, sort of like Google Docs, supports collaborative editing, so you can have multiple people in the same experiment at the same time. Imagine how fun that is. And the studio usage, which again, as I mentioned, is not the time you spend dragging and dropping, it's the time your experiment is running, is billed at, oh my God, $1 an hour. So it's really inexpensive. I have yet to spend more than 15 bucks a month on this thing. Now, when it comes to actually productizing your APIs, things do become more expensive. So the highest performance tier will set you back 8,500 euros, right? But that gives you 50 million transactions per month, right? And if you need more, Microsoft will gladly take more of your money because they're a business. And Azure ML is actually part of something called the Cortana Intelligence Suite, which I don't really want to get into, but it's basically, if you want to produce any sort of insights from data, you need a way to bring in your data set, and there's a lot of technology in Azure that allows you to do that. You need a place to store it. Obviously, you're going to do your analytics on top of it, and then in terms of the UI that you're going to leverage, there's everything from bot frameworks to artificial assistants to Power BI for powerful visualizations and the works, right? The European Union is making life complicated through their GDPR, which is their new law that goes into effect in about 8 months around protecting people's privacy and their rights. So basically what the law says is that if you leverage machine intelligence to impact somebody, like if you decide if you're going to issue a loan based on machine learning algorithm, the consumer has the right to demand to see exactly how that algorithm reached that decision. So imagine how fun that's going to be. References and resources, there's a lot of, if you go to Channel 9, which is sort of like Microsoft's YouTube, and you search for machine learning, there's a lot of sessions that have been presented at other Microsoft-run conferences on the topic. There's here on GitHub, there you go. This second one here is a top-down learning path for machine learning for software engineers. So this is somebody's GitHub page, and they have a ton of links and reference articles to, most of them are free and really, really useful. Questions? I still have 2 boxes of candy. Yes? Yeah. So the first question is if the API is secure. Yes, there is an API key. There's a primary and a secondary API key. So that's how you guarantee access to it. And if you really wanted to, there's a separate, I think it might be API gateway. I haven't used it in a year or two, but there's a separate API management solution that's part of Azure that actually allows you to layer in more sophisticated authentication and billing and metering options as well. So if you produce an API that you think is valuable, you can start charging people to use it as well. But that's a separate Azure product that allows you to do that. But out of the box, I think I pointed to it when I was showing the code. You have to provide an API key when issuing that request. So and those can be regenerated. So that's how it is secured. And I think by default it is only available over HTTPS anyway. So second question?
Yeah, so the second question is how fast the API is, what is happening behind the scene?
Magic. So what's happening behind the scenes? Magic. It's actually executing that trained model. The SLA that you get in terms of the response time depends on the pricing tier. So for dev and test, which is the free one, there's no SLA, but for the paid ones, I don't know off the top of my head how fast they guarantee that they will respond, but in my experience, it's really, really quick. So it's milliseconds, basically. Did that answer your question? Okay. Let's take one or two more, because that's how many boxes of candy I have. Just one. Yes, please.
Have we got any alternatives, open source or free for Azure machine learning?
There are a lot of open source solutions out there. Obviously, Google's got TensorFlow. There's stuff you can run on the desktop. And I was actually, so if you're interested, I'll send you, and if you stop by later, I'll give you a link to the stack that Uber put together, right? So they have their homegrown machine learning technology, and it's built entirely on top of open source components. And they published an article on their engineering blog about how they do it. So it's TensorFlow, Hadoop, Kafka, a couple of other things that they sort of tied together to create their own thing. So if you want to avoid vendor lock-in, that's probably a good way to go. And just one last question. Yes.
What about anomaly detection? Is it as easy as building a prediction?
I do not know. So I can't, I'm sorry, that's over my head in terms of my understanding of the machine learning space. The question was around anomaly detection, sorry. I can't answer that. Thank you guys so much for putting up with me for over an hour. Really appreciate the attention.